In this video, we're going to look at tree diagrams that help us understand probabilities, conditional probabilities, and probabilities involving intersection. We're going to start with a tree diagram that has no values written on it. Instead, it's labeled with generalized probabilities. So we're going to consider an event that occurs first, and that event can have two outcomes, either E or F. And then a second event will occur, and that can have the outcomes of A or B. So this first section is kind of a go button, and we know that we're going to start by saying the first event could have outcomes E or F. And then if event E had occurred first, then the second event has two options. It could either be the outcome of A or the outcome of B. But if F had occurred first, then we could have had the outcome of A or the outcome of B. Labeled on these various branches of our tree diagram, we see probability of E. This first branch represents the probability of E. Down below, we have the probability of F. These two probabilities should add up to 1. Let's go back up to E. If E occurs first, then from E there are two outcomes, either A or B. The probability that is listed on the branch up to A actually represents the conditional situation, the probability of A given E. When we multiply the probability of E with the probability of A given E, we have the result, probability E intersect A. So when we multiply the two branches, we get the probability of E intersect A. Coming down to this branch B, this is the probability of B given E. So E occurred first, you had to go up E first, and then event B occurred. So the intersection of E and B is calculated as a probability of E, the first branch, multiplied with the probability of B given E, the second branch. The second half of this tree is very similar. The trees can be helpful in addition to providing other information, and that information usually has to do with intersections. So once the intersections are calculated, you should notice that the sum of all the intersections should be 1. So if we add P intersect E with E intersect B, with F intersect A, and F intersect B, all of those probabilities add to 1. Also, if I wanted to know the probability of A, then I could add the intersections that all have an A in them. So if I want to know the probability of A, I need the answers for the two end results of these branches. Probability of E intersect A and probability of F intersect A is equal to the probability of A. And that can lead us to being able to answer other questions. I want to move on to an example. At a college, 7 sections of math are taught during the day and 3 sections are taught at night. 85% of the day sections are taught by full-time faculty. 50% of the evening sections are taught by full-time faculty. If Sam has a part-time teacher for her math course, what is the probability she is taking a night class? Let's begin by creating a tree. So we have a situation where we have daytime classes and nighttime classes. Day and night. The day classes are taught by full-time teachers and part-time teachers. The night classes are also taught by full-time teachers and part-time teachers. One tip for setting up your tree diagrams is that on this second level, if it says FP, generally down below, it'll also say FP. Now we need to put our values on. So it had said 7 sections of math are taught during the day and 3 sections are taught at night. Altogether, we're looking at 10 sections. So 7 out of 10 are day. I'm going to write that as 0.7. 3 out of 10, or 0.3, are night. 85% of the day sections are taught by full-time faculty. So the day sections, full-time faculty, 0.85. We know that this combination of branches should add up to a probability of 1. So I need this lower branch to be 0.15. 0.85 plus 0.15 is 1. Going back to the words, 50% of the evening sections are taught by full-time faculty. 50% are by full-time faculty, and that means 50% are by part-time faculty. The question is, if Sam has a part-time teacher for her math class, what is the probability she is taking a night class? So we're trying to solve the probability of night given part-time teacher. So we need to find the intersection of night intersecting with part-time and divide that by part-time. Well, I can find the intersection of night and part-time. The intersection of night and part-time is the branches that combine, N and P, and I multiply those together. To calculate the probability of part-time, I need to notice that part-time occurs in 2 locations on my tree. So I also need to know the probability of day intersecting with part-time. So 0.7 multiplied with 0.15 is 0.105. Adding those together, I can find that the probability of part-time is equal to 0.255. Now I carry out the division and arrive at approximately 0.588. So there is close to a 60% chance that she is taking a night class. One additional example that we'll take a look at is an accounting firm uses a 2-step auditing procedure to find problems in erroneous tax returns. Step 1 identifies the problem in the tax return with a probability of 0.7. Step 2, which is executed only if step 1 fails to locate the problem, identifies the problem with probability of 0.6. So we know step 1 has to occur first. And step 1 has the results of either finding the problem or not finding the problem. And it finds the problem 0.7 or 70% of the time. Step 2 occurs only if step 1 hasn't worked. Now in step 1, there is a 30% chance of not finding the problem. So if they don't find the problem, then they go on to step 2. And step 2 says that it identifies the problem with a probability of 0.6. So step 2 finds the problem 60% of the time and doesn't find the problem 0.4% of the 0.4 or 40% of the time. I know this is 0.4 because I know the numbers on this branch, these 2 branches, must add to 1. I'm going to leave this diagram as is. There are additional questions that we could pose and answer with it.